welcome to our session today, covering Conquering the Security Challenge, Integrating Big Data for the Government Sector. My name is Justin Rapoli. I'm a project manager with ASM Research. With me today, I have Dr. Scott Cochran, who is our lead data analyst, and also Mr. Matthew Boyer, who's our senior application developer and also team lead. Both Scott and Matt have been very integral in supporting our Tableau implementation projects, of which we have several, and we'll dig into those today. So today I'm going to cover ASM Research and who we are, give you a little background on the company. Then we'll dig into a case study, our most recent project involving Tableau, where we implemented a solution for the Army National Guard's Schoolhouse program. The result was that simply by visualizing data, they were able to save more than $20 million in FY14. So then next, we'll dig into how we integrate Tableau into our secure smart card environment. So ASM Research, we're a national company with multiple federal agencies that we currently support across the United States. Our headquarters are in Fairfax, Virginia, and we're approximately 450 employees currently. Some of our core competencies include human capital systems and support, cybersecurity, IA, healthcare IT, and enterprise IT systems. And today we're going to dig into the enterprise IT system sector. So as mentioned before, we have multiple federal agencies that we support. We've earned a very solid reputation with our customers and have an over 90% customer retention rate. One of our customers, and the one that we're going to focus on today and dig into a little bit further, is the Army customer, and in particular the Army National Guard. So when implementing enterprise BI solutions in the enterprise IT system sector of our company, we run across various technical solutions that we drill into. One of them is data warehousing that we've had some significant experience recently with in our implementations of Tableau, as well as data analytics, service-oriented architecture, among other things that you see here. Next, Dr. Cochran is going to dig into our BI design solutions and how we approach that and integrate these systems within our existing applications.
All right, thank you, Justin, and thank you for letting us speak today. So as Justin hinted, a lot of what we do is provide transactional application systems for our government clients. And we're still growing these transactional systems, both in the number of users and the actual number of applications that we run. But in addition, we are adding a layer of business intelligence to sit alongside these transactional systems to aid in visualizing some of the transactional data that our clients have. And one of the problems that we currently have is that a lot of our clients are unfamiliar with the idea of business intelligence. So why should they care? What's the real benefit to them? And so it's our purpose to kind of show them the power of business intelligence that will then sit alongside these transactional systems. So again, we deal mainly with the government sector, and we develop the dashboards for our clients to use. So we develop them, they use them. And we face a lot of interesting challenges in dealing with this government sector. So first is we have 5,000 plus end users, many of which can't install software on their machines. So really they have Microsoft Office products and a web browser. The end users do not have direct access to the data, and they have different roles for accessing the data. And our users currently log in to these pre-existing transactional applications. So we really sit with the client. We work with the client to develop appropriate business intelligence solutions that will be useful to them. So the case study that I'm going to go over today deals with the Army National Guard and support of their training mission. So the Army National Guard uses a lot of web-hosted applications to manage training and training requirements. So each individual in this training pipeline, they have a training seat that's going to be at some particular schoolhouse in a specific state during a fiscal year. There's also going to be a whole bunch of other data. And the bottom line is that it costs money to train these people, and we are here to help the client minimize the training costs. So the goal of this dashboard was to consolidate a lot of the information that arises out of these transactional systems. And what they wanted was to inform schools where these training seats are too expensive, so when they are above or below the national average. And they wanted a very clear indicator of when this occurs. And then they wanted to visualize the additional information that was originating from these transactional systems and where these costs are coming from. And then they can go back and make appropriate changes in the application system. So the requirements that we were given from the client were to gather information from multiple different sources, so our transactional systems, about the seats in the training pipeline, identify inefficiencies, reduce the cost to train by generating a national cost per seat. And then they wanted, for each schoolhouse and each course, they wanted to identify the actual cost it costs to train. And then they wanted a very clear indicator of a potential loss of mission when these training seats are too expensive. So they wanted a go, no-go indicator. So the initial problems that we ran into were, again, we have multiple data sources. This is kind of complex data. There's a lot of different variables going on. Our end users have different needs. They have different access roles to the data. And then how do we integrate this alongside our pre-existing application? So that last part is what Matthew Boyer is going to talk a lot about after I am finished. Okay, so this is the original Excel file that we were given from the client. And this is what they were basing their analysis on previously. So the top column, that shows where all this data is coming from. And so as you can see, there's no real clear indicator as to whether or not a particular course is good or bad in terms of how much it costs to train. And so when I look at this, I don't know what to make of it. There's no clear indicator. Am I good? Am I bad? Do I go? No go? There's there's some shading here, some yellow columns, some red columns, but I don't really know what that means. So this is just too confusing, too complex for an end user to really drill down. So how do we turn this kind of ugly Excel file into a interactive and dynamic dashboard? Not only interactive and dynamic, something that is simple for the end user to use. So who are these end users going to be? They're going to be high-level schoolhouse commanders who have busy schedules, and they want something that they can look at very quickly and get go, no go. Am I good? Am I bad? So how do we do this? Well, we're going to use guided analytics. So we're going to take that Excel file, and we're going to take the key elements. So we're going to take the fiscal year, we're going to take the state, we're going to take school, courses. We're going to aggregate this information starting from the highest level possible and allow the user to drill down to get the information that they need. So after the user has drilled down to a specific course, then we can compute all this relevant information that's going to go into these calculations to calculate the actual cost per seat at for that particular course. And then we're going to give very, very clear indicator of where that course stands. So a go, no-go indicator. If they have a go indicator, they're good to go. If they have a no-go indicator, then there's also going to be other information on this dashboard that they can clearly see. So when our users log in, this is what they're going to initially see. So first they select a state, then they can select a course, then they select a school, then they select a course, and then what they get in the end is a dashboard that looks like this. So under the mission, there's three different indicators. So there can either be a go indicator, a no-go indicator, or something which says that they're right on average. So in this case, this course is right on average, so they have this circle indicator. And so if they had a no-go indicator, then we have these other 4 indicators that they can then drill down and see what they need to improve. So this particular course has 2 go indicators, so they don't really need to work on those areas. Then they have these 2 other no-go indicators. So these are the areas that they can really focus in on. So then some other information that's on this dashboard is the actual cost per seat, how much the total cost for this course is going to be, and then where the national average is going to be. Okay, so this is for a national user. But when a state user logs in, what they're going to see is this. So all they can see is information from their state, even though it looks very similar to the other one, but the only state they can select is their own state. And then any other schools or courses that pertain to that state. Okay, and so what is the end result of all this? Well, after the deployment of this dashboard, the National Guard saw a $20 million savings in operational costs just by being able to visualize their data. So they could easily identify where they needed to improve with these easy-to-read indicators. And all this was done just by taking the existing applications, consolidating this information, and making it simple to use for the end user. And so this is a lot about kind of what we have done, some of the dashboards that we have currently developed. And so now I'm going to turn it over to Matthew Boyer, who's going to tell us much more about how we have done this integration.
How is everyone? Part 2, technical hurdles. I have a few sections we broke this down into. We're going to define the problem. We're going to break down the problem into parts. We're going to look at user management. We're going to look at data restriction. We're going to look at trusted authentication. And finally, we're going to look at application integration, putting it all together. Problem. We've chosen Tableau as a possible data visualization tool. How do we best allow our users to utilize Tableau? How are we going to integrate Tableau into a secure smart card environment? Our scenario, we have 5,000 plus users, many of whom have no permissions to install software on their machines. Our user base is highly distributed. Many users have many different roles. They spend a limited time performing the duties of any one role. End users do not have direct access to the data. Different users have access to different data sets based on pre-existing roles. Users already log into different pre-existing transactional applications. And of course, we have a limited budget. Based on these needs, really our only option for a distributed user base would be the use of Tableau Server. The goal became how to integrate Tableau Server into our existing transactional applications. Integrating Tableau Server had its own set of challenges that had to be overcome. At the time, we had access to Tableau Server version 5 beta. We needed to provide value for our users. We did not want to disrupt our development life cycles for the transactional applications. Major constraint. Our users are required to authenticate using a DoD smart card. In other words, we want to use our pre-existing applications for authentication for all of our users. We also need Tableau to have groups that mimic our own. All of this has to be dynamic on the fly. How are we going to go from Tableau out of the box with username, password authentication, dashboards looking like this, using a setup that's relatively common, which is web applications, Tableau servers, an database server cluster behind the internet and a firewall, to this, where we are logging in using a CAC. And after logging in, one section of our application is going to show all of the dashboards a user has permissions to see. For me, the first step of solving any large problem is to break it down to smaller, more manageable problems. We broke ours into several pieces. User management, which includes creating, deleting users, user permissions. We have the data restriction, Tableau server authentication from an external application, and then an application integration and management, where we tried to put all the pieces back together. Like many web applications, we control access via roles in our transactional system. These roles are based on a set of fields stored in tables in our database. Here, a combination of user type, access type, and state create a set of data permissions that must be followed. So, creating users. We can create users from the command prompt using the tab command create users. I'm sure there's several folks out there that have done that. Easy. How to manage data permissions can be tricky. Tableau has the notion of groups, so putting users into predefined groups is the first step. For every permission group in our transactional application, we created a corresponding group in our Tableau server. We can add users to a group via the command line. Tab command add users. Again, I'm sure there's several of you who've done this. The means exist to add, delete users in Tableau. Users can be added to groups. Now we need to make sure they are managed in our transactional applications. We're going to need to store a few pieces of data. We definitely need to store the Tableau username. We do store the Tableau user password, though we're not really using it. We definitely need to store the Tableau groups a user belongs to. We also, for management reasons, store the Tableau user license a user has. Our sample user table has changed just a little bit. We've added a few fields at the end. Built into Tableau server are command line functions that do what we need. Those functions need to be accessible from our web application. We need to create a wrapper class that calls those functions. We're a .NET shop, so our wrapper class is a .NET class. For technical reasons, we want those functions to be based on a service-oriented architecture. So we then put all those .NET classes into a .NET WCF service that runs on the Tableau server. An example. See here the functions: add user to Tableau, remove user from Tableau, add user to Tableau group, remove user from Tableau group, add Tableau group, remove Tableau group. We can start to see our logic shaping out. We have our pre-existing applications. We have a layer. We can call our .NET WCF service we've created. This will create users, add users to groups. We gather information. Put that into our transactional system so we know what Tableau username and what Tableau groups our users have. Data restriction is very important to us. We have users who should not see other users' data. At this point, the foundation of groups and users is already in place. We use two primary ways to restrict data to the users. Number 1, dashboard permissions are restricted by group. Users who are in a group that has permissions to a dashboard can see and use the dashboard. Those who are not, cannot. 2, embedded in the dashboard logic, which we put in when we create our workbooks, are group checks. Logged into the Tableau server as an admin, I can see several projects. I can see AFAM, ALU, FAI, ITCOP, RBuilder. I can see several of the workbooks that have been created when I drill into a particular project. And if I click on a particular workbook, I can see groups that have permissions. An example. Now, if I were to log into that same server using an ITCOP user, I'm going to see a very different view. The only project this user is going to see is the ITCOP project. The only workbooks are the 4 workbooks from the groups he belongs to. We also make extensive use within the workbook itself, and this is done at design time of the is member of. We add groups we add the appropriate groups into the function when we generate the workbook. If a user were to gain access to a dashboard they should not be viewing, but they're not in one of the groups, the data that comes back is going to be blank. They're still not going to see anything. Tableau server authentication from an external application. This one was the easiest. It's well documented. There's 3 steps. We have to set up the Tableau to trust the application servers. The simple tab admin command. We're going to set the WG server trusted hosts, add our web servers to the trusted IP list. This is a configuration change. We had to write a little code to get a trusted ticket, and we have a little bit of code we've written to embed the URL within our transactional applications. We put the code for getting a trusted ticket and the code for retrieving the embedded URL into a Tableau Core class. See a couple of functions. You have a quick glance at this class we've written. You'll find on the Tableau site, if you do a search, an example that is almost identical to what I've posted here. The application integration logic. It's starting to come together. We have a Tableau dashboard report listing page. From there, we're going to pull back a listing of all the dashboards the user has permissions to see. This includes the embedded URLs. The user will select a dashboard. Our application is going to call the Get Tableau Trusted Ticket. Our application is going to then get the Tableau Trusted URL. We're going to open up in an iframe the dashboard. Here's what it's going to look like from within our transactional application. Login and user management. You still need to put some hooks to integrate our application and Tableau user management. We need a hook into our login page so we retrieve a Tableau username when the user logs in. We need hooks into our user management pages so that when users are added or deleted or change groups, the Tableau server is updated. Here's what the logic's going to look like. We have an application login. The application is going to request a smart card. The user is going to insert their CAC. They'll input their PIN. Our application then will perform smart card authentication. The application will perform login and create a session token. In there, we'll add relevant information, including collecting the Tableau user ID and store that with other user session information. We need some other hooks. We have user management pieces for managing our users. We're going to add a hook to add user to Tableau. We're going to add a hook, remove user from Tableau. We're going to add a hook to add user Tableau group. You get the idea. Finally, what we're looking at when we first started was the internet through our firewall, through our enterprise load balancer and SSL accelerators. We have our pre-existing web applications. We have Tableau servers. The Tableau server exposes its own login. We can't have that accessible from the outside world. On our firewall, we're going to block any access to the Tableau login. Users are going to be redirected to the existing applications. The existing applications will log in the user and then direct them to the... Here, we would normally have a short video presentation that shows our end result. There's a few items that I didn't cover, and I realize all the items were covered at a high level. New with version 8 is the JavaScript API. This allows for much tighter integration. This IP is really cool. It's near and dear to my heart. Our development and production deploy processes are very important. We do have a very specific set of practices so that a Tableau server fits easily into our .NET development environments. We've developed a tool to help us with new dashboard deployment to our production environment. And Tableau has had a predictable upgrade release cycle. We are set up to take advantage of this in our development environment. You should do the same.